Hello everyone, this is Kausi from the Department of Biomedical Engineering at the Engineering College. Today I will be presenting a seminar on spirometry and pulmonary function testing devices as a part of the course, the human assistive device. Let's begin. Respiratory disease are among the leading causes of the illness across the world. Because of this, accurate assessment of lung function becomes extremely important for diagnosis, monitoring, and treatment. Pulmonary functions tests or PFTs are used to evaluate the mechanical function of the lungs, such as how well air moves in and out. Among all PFTs, spirometry is the commonly used tool in clinical practice. It is simple, non-invasive, and highly informative. Spirometry is a diagnostic test that measures airflow and lung volume during breathing. It quantifies how much air a person can inhale, how forcefully they can exhale, and the speed at which air moves. Because it can identify both obstructive disorder like asthma and COPD and restrictive disorder the pulmonary fibrosis. Spirometry is widely used in hospitals, clinics, and even community health screenings. Next, the clinical applications of the spirometry. Clinically, the spirometry plays a vital important role. It helps in the early detection of disease such as asthma and COPD. It is also used to monitor disease progression over time. Before surgeries, spirometry helps evaluate whether the patient's lungs are fit for anesthesia. It also helps assess the effectiveness of treatment, especially bronchodilatry therapy. Additionally, spirometry is essential in occupational health screening, especially for workers exposed to dust, fumes, or chemicals. Several important parameters are obtained from spirometry, that is FVC, forced vital capacity, the total amount of air exhaled forcefully after a deep breath. The next one is FEV1, forced expiratory volume in 1 second. It means the amount of air expelled in the first second of forced exhalation. The next one, FEV1 or FVC ratio. It is the ratio helps distinguish obstructive from restrictive disease, and also it is a differentiate the ratio between obstructive and restrictive disorders. And the last one is PEF, peak expiratory flow. It is the maximum flow or speed of air during exhalation. These parameters guide clinicians in diagnosing and classifying lung problems. Next, the principle of spirometry. The principle of spirometry operates mainly using two principles. The one is volume displacement, where the actual exhaled volume is measured directly using a chamber or bell. The next one is flow sensing, where the device measures the rate of airflow using sensor, the pneumographic tubiness or ultrasonic transducer, and then calculate the value. Modern spirometers mainly use flow sensors because they are compact, fast, and highly accurate. Next, the types of spirometers. Based on the working principle, the spirometer classified into volume displacement spirometers such as air, water seal spirometers and bellows spirometers, and flow sensing spirometers, which include pneumatograph, turbine or rotary vane sensors, hot wire anemometers, ultrasonic spirometers. Each type has their own advantage depending on the applications. Next, the pulmonary functioning testing. Pulmonary functioning testing or PFT is a larger group of non-invasive tests used to evaluate lung ventilation, airflow, lung volumes, and gas exchange. These tests help diagnose obstructive disease, restrictive lung disease, diffusion abnormalities. They are used for early detection, monitoring disease progression, surgical assessment, and also evaluating treatment responses. Next, the PFT devices. The PFT devices, several devices are used in pulmonary testing. That is, spirometer measures airflow and lung volumes, Next, the body plethysmograph. Based on Boyle's law, measures absolute lung volume like total lung capacity and residual volume. The next one is DLCO devices, that is diffusion capacity devices, that is used to measure diffusion capacity across alveoli. The another one is peak flow meter. It's a simple device for used to asthma monitoring. Then impulse oscillometry called IOS or FOT. It used to measure airway resistance using sound waves, especially used for children. The next last one is gas analyzers. It measures oxygen and carbon dioxide level for advanced PFTs. Together they provide a complete picture of lung function. Next, the clinical applications of the pulmonary functioning testing devices. The PFTs are used in several clinical scenarios like diagnosis, monitoring, treatment assessment, preoperative assessment, and occupational health. In diagnosis, it used to diagnose asthma, COPD, pulmonary fibrosis, and other respiratory disorders. In monitoring, it used to tracking the progression of the chronic and lung disease. In treatment assessment, it used to evaluate the response to bronchodilators or steroid therapy. In preoperative assessment, it used to ensure a patient's lung can tolerate surgery. And last, in occupational health, it used to essential for screening workers exposed to dust, fumes, and chemicals. The parameters used in PFTs are, in addition to spirometric values, PFTs also measure TLC, RV. The TLC means total lung volume capacity, and also RV means residual value. These values give deeper insight into restrictive and obstructive patterns. Thank you for listening. Thank you.